Welcome. This video is CCBYNC. Welcome back, everybody. This is the first part in a 5-part series of how to graph trigonometric functions. So we're going to start out with graphing y equals sine of x and y equals cosine of x. And what I do is I set up a nice xy table here. This is actually an xy table. And I want to talk about when x equals 0, what is the sign of 0? That is 0. What's the cosine of 0? That's 1. Again, you could look at a unit circle and see that. Next up, pi over 4, root 2 over 2 for both. And actually, if we divide that out, we get 0.707-ish. Pi over 2, sine is at 1, cosine is at 0. 3 pi over 4. Now 3 pi over 4, we're in quadrant 2. And in quadrant 2, x is negative, which means cosine is negative. So we end up with root 2 over 2. And for cosine, it's negative root 2 over 2. At pi, sine is back down to 0. Cosine is at negative 1. At 5 pi over 4, that's in quadrant 3. In quadrant 3, both x and y, or sine and cosine, are both negative. So this is negative root 2 over 2, which again is going to approximately be negative 0.707. 3 pi over 2, sine is set down at negative 1. Cosine is back to 0. 7 pi over 4, that's quadrant 4. In quadrant 4, sine is positive, negative, and cosine is positive. So we have negative root 2 over 2. And positive root 2 over 2. And back to 2 pi, it's going to be the same as 0 here, 0 and 1. And before we get going on this, I really want to highlight where these points are. And let's talk domain of a sine and cosine, actually. If you remember from your algebra class, domain are the x values that we are allowed to use. And in the case of sine and cosine, the domain is negative infinity to infinity. We have no boundaries in the x direction. In the y direction, however, we peak out at 1 and we bottom out at negative 1 for both graphs. And I want to talk about some of the major points here. There's going to be 5 critical points. So let me write the range down. Range is from negative 1 to 1. The critical values this is going to break the graph down into 4 pieces. That's going to be down here at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I'd like to mark up where these are. I'm also going to fill in, just real quick. Here's my pi over 4. And here is my 3 pi over 4. And then 5 pi over 4 is here. And here's my 7 pi over 4. And the ones in black are actually my critical values. So here is our sine wave. We start down here at 0, 0. At pi over 4, I'm going to add about, and I'm going to label this as 1, and down here as negative 1. So I'm going to go to my critical value. I start down here at 0. I go up to 1. I go back down here to 0 when I'm at pi. Then down to negative 1 at 3 pi over 2. And then back to 2 pi. And we can see we have our sine wave. And you can see when I'm at pi over 4, it is positive about 70% of the way up for both. And then the two negative ones are down here, right there, and right there. So there is our sine wave. This is y equals sine of x. And to be clear, this graph actually continues on in both directions, and it keeps oscillating. And you'll notice part of the time it's above the x-axis, part of the time it's below the x-axis, meaning it's going from y is positive to y is negative, and it's alternating forever and ever in both directions. Next up, let's do cosine. Again, the domain for cosine and range are the same. So this one's y equals cosine x. And cosine is going to get broken up the exact same way. This is pi over 4. This is 3 pi over 4. This is 5 pi over 4, and this is 7 pi over 4. And once again, I want to point out my critical values are the same as the sine wave. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when x is 0, cosine is up here at 1. Let me label the y-axis as well. So I actually start up here. Then I go back down to 0 at pi over 2, 0. Then down to -1 at pi. Then back up to 0 at 3 pi over 2. Then back up to 1. And you can see it's actually exactly that graph there, but it's shifted over, right? You can see that this goes to the sine wave once again. So again, this keeps on going forever and ever. And that actually is true of both the sine wave and the cosine wave. They are shifts of one another. And we'll talk more about that in another video. Let's talk amplitude. So I'd like to point out for these two, the coefficient is a 1 times sine x, 1 times cosine x. We're going to say, what if it's no longer a 1? What if it's something other than that? And that brings us to amplitude. So once again, sine of 0 is 0. Sine of 0 is 0 times 3 is still 0. And sine of 0 is 0 times -1/2 is still 0. So those don't change. Sine of pi over 2 is 1. Now sine of pi over 2 is 1, but this is 1 times 3. So this actually goes up to 3. And this one, sine of pi over 2 is 1 times -1/2. That's going to be -1/2. Sine of pi is 0, 0, 0 for these. Sine of 3 pi over 2 is -1, but -1 times 3 is going to be -3. And -1 times -1/2 is a positive 1/2. Then at 2 pi, we're back down to 0, 0, 0 again. Now, once again, our critical values in this case are going to remain the same. And those are going to be at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So what we're going to do is we're going to graph all three of these, and the number in front is called the amplitude. And we're going to see how the various graphs are affected by that. First, I'm going to graph a regular old sine wave. So that starts here, goes up to, and I'm going to label this 1 and this one -1. So we start down here at 0. I'm going to go up to 1, go back down to 0, down to -1, back to 0. So here's our regular sine wave. And let's see what happens when we graph. So I'm going to underline this one blue, meaning that's the blue graph. Next up, we're going to have a green graph for this one. And for this one, we're going to start at 0. But when we hit pi over 2, we're going to go up to 3. If it's 1, then 2, then 3. So I'm way up here. back down to 0, down to -3, and back to 0. And you can see the 3 in front, the amplitude, makes it peak much higher and valley much lower. And for our -1/2 sine x, we're starting once again at 0. Then we go down to 1/2, so just halfway down there. Then back up to 0. Then only halfway up, and then back down to 0. Notice we start downward. So a smaller amplitude makes it much closer to the x-axis as we do that. And so what's our takeaway from this? Our summary. Oh, when we have the function y equals a sine of x, or the function y equals a cosine of x, if a, absolute value of a actually, we only want the positive, is bigger than 1, then it is larger. Larger peaks and valleys. If the absolute value of a is less than 1, then it's smaller. I hope that you found that helpful.